Can you hear me all right? I guess. Okay, excellent. Thank you for coming. So what we're going to talk about today is how do you consume Azure ML services in Dynamics AX. So I guess you all heard in the keynote, Mike Ehrenberg mentioned about machine learning. And he also mentioned about a customer called JJ Foods. Are you familiar with this case study? Have you seen it being presented, or have you read any blogs anywhere? How many people are familiar with it? OK, so that's good. So there's new content for everyone, and people who are familiar will see much more detail about what we have done with this customer. So thank you. So this is exciting times. It's very new technology, and the applications are just as many as you want. It's just, so I want you to leave with this impression that machine learning is not something which is very hard or very complicated, and it's not something which is only in the cloud world. It's very much here, and we can all use it, and there's many, many scenarios where we can integrate whatever applications you're using, whether it's Dynamics AX, CRM, NAV, anything else that you're using. So what I'm going to do is do a little bit of introduction on why machine learning is important and where and how we think it fits into the work that we do. Then we're going to see some demos on how JJ Food uses machine learning in their environment. And then we're going to talk about some business outcomes. That's essential that whatever technology we're building is actually bringing them some benefits. So we're going to talk about what benefits they have received from this. Then we're going to dig a little bit, well, I won't say deeper, but an introduction to what Azure ML is and why it's been created and how it can be used. Then we're going to spend more time talking about scenarios within, or let's say, how you can integrate within Dynamics. Okay, so there are some things which are in the works now, and there is a lot of other scenarios which I want you to sort of think through and see how these apply in your business in whatever you do. And then, so start a dialogue, really. It's still new, but people are thinking about it. So I want us to have a dialogue in the end. So you leave with some real scenarios where you can actually use it, OK? And then I'll summarize towards the end. OK, so let's get started. So what I want to paint here is a very, very simple picture, just so everybody, it's easier to start with something very basic. So let's talk about a simple business process. Let's say there's a customer, and there's a web shop, and there are Dynamics. And there's something else, which is a decision management tool. So for every business process, as you know, a number of decisions are being made all the time, right? And this decision management tool could be part of Dynamics, or it could be a separate tool. So the scenario is a customer logs onto the portal. The product catalog, in this case, is residing in Dynamics. Now, the first decision that needs to be made here is what products to present, right? And you could argue that this decision doesn't really have to be made. Lots of web shops, you just log on, and they show all the products. But still, if you want to optimize, then you would want to present some products which are personalized. Once the decision is made by the tool, the products are presented. And then the customer puts the item into the cart. Again, the product information comes from Dynamics. Another decision needs to be made here. So what other products is customer likely to buy, right? Again, the same thing. Somebody needs to make this decision. The key point is the decision needs to be taken somehow. Whatever products are recommended, they are presented. And then just to complete the business process, simplest thing is that the customer will check out. And again, you could argue there's another decision to be made here. I can use the clicker, I think. Based on the basket that he has so far, what other things can he buy, OK? And then those recommendations are presented. So this is very simplistic. But really what I want to point out is a lot of decisions are being made in this process. Now, in the past, long time ago, all these decisions were coded. But of course, we have most of the applications now have rule-based engines to make all these decisions, right? So, for instance, in Dynamics AX, we have cross-sell and upsell capability. I don't know how many people are aware of the cross-sell and upsell. Sure. Okay, so few of you are aware. So that is like a rule, right? So, but you have to set it up, right, for every product, what other products can be sold. All these rules, they need to be set up. There's many, many different areas wherever you're setting up rules in Dynamics or in another ERP. So the key point here is that if we could augment these rules with machine learning technologies, which could be descriptive or which could be predictive. It doesn't always have to predict something, right? So the key thing here is, again, instead of hard coding business rules, and which is great compared to where we come from, but again, there is a limitation on it. So if the business changes, somebody has to go and modify the rules, or the rules have to be such that they take care of all situations, which is usually not the case. Whereas if we can augment these rules with machine learning predictions, then, as you will see in the following scenarios, it makes the application much more flexible. Then the other thing is that, so I showed a very simple business process. There were 3 decisions being made. Now imagine if you were to take out all these points where you were making decisions, pick any business process which is relevant, and analyze how many decisions you're making in that business process. And then if you were to bring in machine learning, bring in some intelligence into all these decisions along the business process, then you move into a domain which is known as prescriptive analytics. So you have a very prescriptive process, which takes into account a lot of other things other than the information in your Dynamics and other than the rule engine in your Dynamics. Now, what also this helps you do is you transform your automated business process into an intelligent business process. So with Dynamics or with another ERP, you make your process automated. With machine learning, you can make it more intelligent. You can add smarts to whatever process you're working with. So that's really a very short intro to why we think machine learning is very hot. The other thing is to talk about why machine learning, why Azure ML. So first of all, like I said, rule-based systems, Dynamics, ERP, you have a database. You have some data there. But by using Azure Machine Learning, you have the capability to use multiple data sources, right? So you can have, of course, your SQL. You can have data coming from somewhere else. You can have Twitter feeds. You can have clickstream data. You can have data from other systems like Hadoop. The next thing is compute. Some of these algorithms are very compute intensive, and it will just not be possible to run them. Well, it is possible, but then you will need a farm of computers just to do a small prediction. Mobility. So Azure ML, as we'll see a little bit further, allows you to work with just the REST API. So when the model is built, let's call it a predictive model, when it's built, then it can be deployed just as a web service. That is the coolest thing, I think, in the Azure ML platform, that you can call this service in whatever application you are in. And that's what cloud allows you to do. You don't have to make individual integrations to all the applications. Then the next thing is simplicity. We'll see how easy it is to drag and drop and create a model, more or less. Then flexibility. And again, I mentioned the flexibility part earlier. So it allows you, so since you're not working with rules, but you're working with just the REST API, it makes the business very flexible. So people who have a background in analytics of this kind would know that in the past, it would take months to create a model like this, and it would take another month or so to deploy the model. This used to be what people did with other tools in the past. But with Azure ML Platform, it takes hours, not months, for some of the models. Of course, you need to, if you get into that level, the thing is that you have the tools, if you have the knowledge, but you need some data science knowledge in certain areas. If you have the knowledge, it becomes really, really easy because you have the tools. It takes only hours. Sometimes it'll take a day or two to create a model and deploy it. So it's no longer the case that by the time you're done with your model deployment and ready to consume results, the business has already changed and they want you to do something else. So that's about time to value being very short. So that's an intro to where I think we can use Azure ML. And now I'll go and talk about the customer and then. So let me take 5 minutes here so everybody understands what JJ Food is and what they do. So it's a food wholesaler and distributor. Okay, and they cater to the catering industry in UK. So who are their customers? So this is a B2B environment. Okay, so their customers are restaurants and pubs and bars and cafes, schools, and they also do event catering. So it's important to know that this is a B2B environment. The technology we are using for JJ Foods was initially developed for a B2C environment. Now, they have about 60,000 customers, 8 different sites, 4,500 unique products, 1 million sales orders, and approximately 200 million pounds turnover. So not a very massive customer, a medium-sized customer, but even for a medium-sized customer, as we will see, there are scenarios where it becomes the compute required to do some predictions can be very intensive. So to understand their business a little bit better, so what do? So they take orders all through the day until 9 p.m. Okay? They take orders mostly through 2 channels. They have a web shop and they have a call center. So they started with call center operation on Dynamics AX, I think about 5-6 years ago. And now, then they went on to create a web shop. So they have 2 main channels. They also have some retailing, so people can come and buy in their warehouses, but that's a very small part. Then the transport. So after 9 p.m., when all the orders have been come, there are people who use different technologies to make sure that vehicles are routed based on the deliveries that have to be made next day, and drivers are assigned for these vehicles. And then the warehouse picking has to happen. So they have multi-temperature products. Some products are frozen, others are chilled, and others are ambient temperature. So all the warehouse picking happens, of course, after the orders have been collected and everything is ready. So it goes on to, I think it starts at 5 in the morning. And then the loading of the trucks. And then, so truck loading happens at 5 in the morning. And after that, there's delivery. So, and the trucks leave the campus at about 8 o'clock or something and deliver throughout the day. So fairly simple process, right? I mean, of course, all of us know it's more complicated than that in the back end, but the idea is to present this in a way that you can see that you can apply machine learning to many, many different scenarios. So this is what JJ does, right? Now let's see, what were the key challenges? Why did they actually want us to do this at all? So just key points here. So it's a B2B business. Okay, it's low value and high volume. They're simple food products. The market is very competitive. There are many, many companies who do this. And they only think, so it's very important for JJ to differentiate on customer experience. That's the key point here. Customer experience is the key point. And now, the challenges that they had, so when they were using the call center, it was relatively easy for call center agents to do some cross-selling or upselling. Okay, so the customer is calling you and saying, look, I want these things in my basket. And once the call center agent has done that, then the call center agent can go to the customer and on the phone and say, look, do you want these other products? They are on promotion or something like that. But they wanted to move to the web shop because many people wanted to order online. And once they moved to web shop, it's a common problem for everyone, right? Once they move to web shop, there is no hand-holding. There is no guided selling, right? So they lost that possibility with the web shop to do any cross-selling. The next thing, like I said, customer experience is very big for them, and so they want to improve even further on that, so improving the customer service. They want to continue to retain customers since all these products are really low value and there's not a lot in switching the suppliers for most of these customers, so it's harder sometimes to retain customers. And then they wanted to achieve all of that and still do it at a budget which does not break the bank. So those are the key challenges. Now, so this slide actually talks about different things here. So a couple of things to note here is there is something called Azure ML Apps, and there is another thing called Azure ML Studio. So if you go to Marketplace in Azure and Data Services, you can see a number of Azure ML apps which are available there. Okay, so Azure ML App is really something where we don't want you to have the data science knowledge. So we package it in a way that all the calculation happens in the background. You just give the data to it, and it'll publish an API, and then you use the API. Okay? Now, Azure ML Studio, on the other hand, is where you need some data science. Even though it's been made very easy, you can drag and drop, but at least you need to know what different algorithms are doing, what kind of problems can be solved with these algorithms. So if you have data science knowledge of fairly high level, you can start building the models. But as you go further, you will realize that with Azure ML Studio, you would need R programming knowledge, and you will need some more data science, math, and statistics background. So what we've done with JJ is we have 4 Azure ML apps, and we built some specific models for them using Azure ML Studio. And then we have integrated some of these services to Dynamics AX. Now, when I do the demo, I'm going to show the frequently bought together. So how many are familiar with the frequently bought together? Right, so almost everybody. If you go to Amazon.com, if you buy something, you will always have these. If you buy a computer, they'll suggest you to buy a mouse and things like that. So that's frequently bought together, more or less. In a similar vein, but still very different as far as the background algorithms are concerned, are item-specific recommendations and basket-specific recommendations. Then customer churn. I will not be talking about customer churn today, but very simply, it's a way to know, based on your past transaction history, which customers are likely to stay with you in the next month. Okay? And this helps once you know customer churn, what the churn rate is. You can use this to do something called uplift modeling, which is how do you want to make sure that your marketing budget is being used well and is being used to retain customers, and you're targeting your promotions on, you're making sure that customers stay with you. That's really all about uplift modeling. But that's a completely different subject. And then I'm going to show you the integration to Dynamics AX. Okay, so let me see. So next stage, demos. Okay, so that's the web shop of JJ Food Service, and I'm logged on to their test server. Now, so when, think of me as let's say a restaurant customer. Okay, so I go here on the web shop, and I see all these things. Now, this is called the order pad. Now, the first thing that they have done here is something called basket prediction. So they predict for you things that you're likely to buy today. Okay, and this is not an app. This is made in the studio. So handcrafted with lots of drag and drop, plus also some code. So this tries to make a prediction based on your past history. So I'll show you this a little bit more, and when I talk about this, when I show you the studio, then I'll talk about this particular service. But what is the purpose of this? Right? It's important to understand this is a B2B business. If this was something else, B2C, then you would probably want your customers to spend a lot of time on your website. You would want them to click everywhere. You would want, you'll show different things to them. You will want them to spend as much time on your website as possible. But in this case, these are busy people who are placing orders. So these are usually restaurant chefs or some manager in the restaurant who has many things to do, many places to make orders from. So he's busy. So the idea here is that he should spend as little time placing an order as possible. Okay? And the same thing applies in the call center. And that is the reason why we kind of predict in this scenario. So we don't want the customer to go and search for the product that he's looking for, or to scroll down, or to go to the next page or anything like that. So it's like a quick order taking scenario, which is there, and we do with Dynamics. There are many solutions which help you do that. It's something similar, but we think a little bit more smarter than that. Now, so that's the first thing, basket prediction. Now, the next thing that I want to show here is that you see this product on the right-hand corner. It's a tomato paste. And here I can add the tomato paste. So let's say I want just one of these. I can click on it. And what it does is it slides out, and it brings another paste. So the system is suggesting you at this point that you should go and buy mild pepper paste. Okay? So what happened right now is a call to Azure ML was made with tomato paste as the seed item. And it goes in the back end, and it does all the calculation. It has looked at all the patterns of past 3 years' data, and it says that maybe you should also buy, or maybe you should consider buying mild pepper paste, because these two things are usually bought together. So if I, for instance, go here, and this is a frozen mix of vegetables. If I click on this one, then it comes and says, oh, you should also buy frozen cut green beans. Same scenario, same situation, a different seed item, and a different recommendation. Okay, so if I click on it, it gets added. You see, on the top here, I'm building my shopping cart. So it gets added here in the shopping cart.
Is the rule considering campaigns on items as well?
So Thomas, I'll take the questions just after the demo. I'll remember that one, okay? Okay, now, and if I click on, let's say, these prawns here, there is no recommendation, okay? So the system does not provide recommendation every time. Again, we don't want too many things popping up. We set up certain thresholds, and these thresholds are actually in this scenario set up in AX. So the model will recommend you every time. Whenever model has its own thresholds and own scoring and relevance and so on, we'll talk about that. So model recommends you items for every click, but then you can decide on the front end whether you want to expose that or not. So the score probably for the prawns recommendation is not high enough, and therefore it doesn't show here. So that's usually bought together or frequently bought together. Now the other, so we've seen two right now, basket prediction, which we haven't really seen, but you have to trust me that it is there. And the second one is frequently bought together. Now, if I click on one of the items here, so this is cooking oil. If I click on the cooking oil, it goes to the item landing page, right? Every storefront will have something like that. And then on the item landing page, it gives us further recommendations here. So these are what we believe people who have looked at or bought the cooking oil, they have also considered these recommendations would probably be relevant for you. And here we see that there is a recommendation for chips or fries, and there is a recommendation for some, I think, chicken product, some sugar, some mutton products, and some fish. Okay? So this is called the item-specific recommendation. There's a different model which runs in the background for this. And now if I go back to let me add a few from here. Let's see if this is available. And so when I say this is available, so what's happening here is that, so we don't, the purpose of this is to help you. So all the ATP check and everything else is already running in AX. Okay, so if it's not available, then it's just not going to add it, right? So that's what I mean by through the business process, identify the decisions and plug the machine learning there, so that you can augment whatever decisions you are making in whichever way you are making. But you don't have to modify the business process. The business process still is there. ATP check is still happening. Let me add this one. Let me add this one. Okay, not allowed quantity for whatever reason. Maybe they don't have this. Okay, so we've got a few items here. Let's go back to the order pad. And notice that these restaurants also order a lot of cleaning products. So, and there are some recommendations for cleaning products as well. So I'm going to add a few cleaning products to our basket. Okay, so until now you have seen basket prediction, you have seen frequently bought together, item-specific recommendation. Now the last one is here. So now this you see on the top, we are ready to check out. So we have all these things in the basket, and I'm going to do a checkout here. And when I do checkout, then again there is a set of recommendations. Okay. So the key point here is we want to improve the customer service, right? So we want to make the experience really simple, and that's why we do the basket prediction, we expose the items we think you're likely to buy, so you spend less time on the website. But at the same time, we also want to do cross-sell and upsell, right? So we want to improve customer service and increase the business, and that's why these recommendations are still coming. But we manage the recommendations in the backend in AX to make sure that your experience is not, it's not taking too long, and the recommendations are popping up all the time. Okay. Now, so that's all happening on the website. Okay. Now let's see what's possible on AX. Okay, so now let me just go out of this if I can. Let me close here. Okay, so that's Dynamics AX, and this is a custom-developed call center capability. So call center came in AX very recently, but these people have modified AX about 5 years ago to have this. So now if I go to the order pad here, so now imagine a call center agent. Okay, he's on the phone, and customer calls. Call center agent picks up, goes to the order pad, and on the order pad, based on who has called, chooses a customer. And let me put the number here. I say go. Okay, so this is, don't have to worry about all the detail there. There's many different accounts for the customer and so on. The thing that I want to point out here is something called customer classification. Okay, so this classification is actually coming from Azure ML as well. So it's really, this is not a prediction, it's more of data mining. But what it allows us to do is that, and so first of all, this is data mining, and secondly, like you saw frequently bought together and the other recommendations, they are online real time, all the time. Customer classification needs to run only once in a month. Okay, so you take the monthly data, add it to the previous year's data that you have, and then you calculate the classification. So you can do many different things with this classification, right? Simple mining algorithm, but it's very helpful for the call center agent. So call center agent can see the history here, that the customer has been gold and, gold for 2 years, then diamond, then gold, diamond, gold. So it's kind of fluctuating on the top bracket. And then you can use this information to do various things, right? So call center agent has the flexibility to see this information and say, okay, this is a very good customer, so maybe, if the slot that the customer is asking to pick his stuff in already filled or something else, then call center agent can use this information really. That's the purpose, to make different decisions. And we can embed this within Dynamics AX product for various scenarios, okay? Now, so this is called customer classification. Now let's start taking the order, okay? So customer is on the phone, and we don't want to delay the customer anymore. So we go into the order taking screen, and then we go into the lines. Now, there are different colors here, and there's many different things going on. But what this is the order pad again, right? The thing that you saw on the web shop is the same thing that's displayed here. So again, basket prediction is running in the background and giving you these items. The other thing that basket prediction also does is it sequences the items in the order that you are likely to buy. So it's a little too smart sometimes, I think, and I don't know if it's actually working or not, but the key idea here is, and this is where it takes a little bit of fine-tuning, the key idea here is that everybody who places an order works off a shopping list, right? So if a particular restaurant owner always orders meat products first and then orders milk products and then orders something else, so we want to also mine that pattern within the data and then expose the order pad in a way that those items are categorized in that sequence. Okay, so I want to make it really, really quick. And that happens in the web shop and happens here as well. So now what I'm going to do here is simply just start taking some items. So let's just imagine that the customer wants some lemonade bottles, some frozen fish, some toilet tissues. And so what I'm doing is just taking the orders for the items that customer is saying that they want, and then putting them in the shopping basket. Okay, so this is, when I put them in the shopping basket, that has no machine learning in the background. That's simple, their customizations. Now, at this point, my basket is ready, and you can see the items in the green here in the bottom. These are all the items that the customers asked me to buy. Now, there is a button here. It says Show Recommendations. So I click on that button, and what happened just now was, again, based on the basket, based on all the items in the basket, a call was made to the Azure ML. Like I said, there's an API which takes your seed items and the payload, and then recommends us some items. Okay, so the call center agent now doesn't have to dream up items, doesn't have to look on a piece of paper, or doesn't have to look somewhere else where there might be some promotions. They can just, click on the button, and these are real life, online, real time, being updated as often you train the model. Okay? You can hide the recommendations, or you can add the recommended items to your basket. So this is what we think is very cool, right? So you have a very, significantly complex model running in Azure ML, and you have a number of applications which have been designed by the Azure services teams. So we're consuming the results from the Azure ML services, and we're consuming the results from the handcrafted Azure ML model in the Azure Studio. And we're integrating them to Dynamics AX, right? This can be done to CRM. This can be done to various areas. It's really open. And this is what I want you to leave with the opportunity and the possibility of actually augmenting every place you see rule-based engines being used in Dynamics. Okay, so that was the demo part. Switch over to the PowerPoint now and use my clicker. Okay, so those are some slides. Right, so here what I want to quickly mention here is this is the basket prediction model on the left, but we'll see this in the studio, so don't worry about that. But on the right, what I want to show you is the parameters that have been set up in Dynamics. And this is custom right now, but everybody can do that, or we can put that in the product. Right, so using these parameters is basically, so there are parameters which help you decide where the data needs to go to be fed into the model, okay? And then there are parameters that you put in to filter the results to make sure that, like I mentioned, right, there were some items which did not have any recommendation. Those are the parameters you can set up in Dynamics, okay? So we've seen those demos. Okay, now I mentioned about mobility. Why Azure ML? Because you can consume that API anywhere. So what the customer has done actually is going forward, this will be possible to see the recommendations on a mobile device. So they run some Google Analytics on the web shop, and they have found that a lot of customers are actually using mobile devices to place their orders. So they want to make this experience really smooth for them. So they have built an app which you can, well, if you want to order from JJ Foods, you can download that. It's available in Google and Apple right now. It'll be available in Windows Phone soon. And when you are placing an order using this app, I don't have the app running, so I have some screenshots. When you're placing the orders using the app, then the recommendations will surface again. So right now, this is a live call from every mobile device to Azure ML to provide these recommendations based on what the customer is ordering. So the first place you see is somebody is looking at the product details. And there are 3 tabs within the product details. One of them is actually detail, and the other one is recommendation. So if you have to, I think, go here. So if the customer clicks on the recommendations button, then they will see the item-specific recommendations, the second recommendations that I showed. And then you can, so let's say you have done that, you've added all these items into your cart, and now you're ready to check out. So this is all the items in your cart, and then if you press the checkout button here, you will get some more recommendations. So both item-specific recommendations and basket-specific recommendations, which run off a same model and which are Azure ML apps and not in the studio, all these recommendations will show up on your phone. Okay? You like it so far? Okay. Now, so what is actually happening here? So let's take 5 minutes here and talk about how this actually happens. So like I mentioned, the basket prediction is done in the studio, and we'll see what it is. It's basically doing some pattern mining. Okay? It's a mining thing which you can do with current tools as well. But like I said, the basic thing we are using, we like here, is the Azure ML platform, which allows you to publish something as an API. This is not available in any competitive products either. And that, plus the fact that it is flexible to change, yeah, that's really the key reason why we use Azure ML Studio here. And the remaining 3 apps, they are coming from an Azure ML app. Okay? So like I mentioned, ML apps are something which are packaged and ready to go, and they don't need data science. But we still want to know what's happening in the background, right? So the code, etc., is not exposed for these apps. They work like a black box. But so let's take frequently bought together. So this is, again, pattern mining. Okay? But think about it. It's only, so they have 4,500 products, but we are only working with 3,000 products here. But even with 3,000 products, right? So we tell this algorithm that we want to know, let's say, what are the 3 items that always are together in the checkout, in the cart. Okay, so look for this pattern through this data. Now, there are 3,000 items that we are working with, and that makes up to 27 billion possibilities. If you were to use any simple algorithm, it will take forever to compute that. And that's the reason we had to use something which is built in the Azure ML apps. So, so the algorithm is smart enough, advanced enough to actually finish this job in a reasonable time. So what it does is, so it has this request. So we tell it that look for 3 items that always go together, right? So that's a pattern. We have already told that this is a pattern we are looking for. So it goes through all these combinations, and then looks at all these patterns, and then does an array of statistical tests to find which of these patterns are relevant. So let me give you an example. So for instance, everybody who comes to JJ website would probably order some milk, or order some bread, or order some products like that. So these products will appear in every basket, together with the tomato paste and together with the cooking oil, right? Now, if you were to make this as a rule-based system or do some coding, it will be a little hard without math and statistics behind it. So what we don't want is that whenever somebody is buying cooking oil, we show them bread and milk. Whenever somebody is buying tomato paste, we show them bread and milk. That won't be very cool, right? Because bread and milk is in every basket. So, so we need to do something in the background to take the only relevant results. We want to differentiate between things that are happening by coincidence and things that are happening intentionally. Okay? So it's just a coincidence that milk and bread come together all the time. We don't want to show you that as a recommendation. We want to identify things which intentionally are being put together. So that's how frequently bought together app will work, and that's the background to it. Now, item-specific recommendations is based on something called collaborative filtering. And within collaborative filtering, it uses something called latent factor model. And what does latent factor mean? So in the previous case, we told the algorithm a particular pattern. We said that, okay, look for all those items, 3 items which are bought together. Okay? But in this case, we do not tell any pattern to the system. Item-specific recommendations algorithms will identify the latent factors which run your business in the background. And they will pick a factor. So for instance, when I showed the cooking oil example, when we click on cooking oil, the item-specific recommendations showed like chicken products and fries and mutton product and sugar and some other things. Okay, so there is a latent factor here which a model has identified that cooking oil is used for cooking. So try to show the products which are most often cooked. So cooking is kind of a latent factor which apparently is very relevant as compared to other latent factors. So the model will look at the data, identify the pattern, and identify the factor, latent factor, and then stack those latent factors based on the relevance and discard the ones which are not interesting. And after stacking all those, then it will rank them. Okay? So there is what we use here is something which was invented by Xbox team. It's called the Xbox Recommender System, and it's one of the world's best recommendation systems that is being used in this app. So now if you remember in the cooking oil example, we also had the granulated sugar, right? That's kind of a, why do we have it there? And what the model can do is it can merge two different latent factors. So one latent factor is cooking, and the other latent factor is these are kind of basic products, cooking oil and sugar. They are basic products. So the latent factor there is basic product. And there is complicated math behind it, which will decide whether it's useful to present granulated sugar here or table salt there or milk, which is also basic product. Now, the machine learning challenge here is really to present stuff which is relevant, right? So the milk and bread example, that's finding out what's relevant. And then the other thing is novelty. Now, you see, so we did the order pad, right? We did the basket prediction on the order pad. But what we achieved with the basket prediction was we made it very, very simple and fast for the customers to order stuff. But if we only present the products to the customer, which he normally buys from you, we're not going to end up making any new business, right? And therefore, we added some recommendations. And within the recommendations, we have to expose some novel products. Some products which customer doesn't always buy or has never bought, right? But might still be relevant. They are novel for the customer, and they're relevant for the customer. So this is called exposing the darker parts of your catalog in the terminology. So there are darker parts of your catalog which the customer is not aware. Customer always comes to you and buys a fixed number of items from you, and he doesn't even know that there are other things that you can supply. Okay, so this happens automatically. Instead of you having to build a rule saying, if this happens, this happens, this happens, then you do this cross-sell. If this happens, this happens, this happens, then you do that upsell, right? There will be so many rules required to be hand-coded, handcrafted, modified, if you were to do this in a normal application. Then the last point is to maintain diversity. So if you, again, going back to the cooking oil example, we presented one bag of fries, right? We could also present like 5 bags of fries. Right? They have 5 different fries in JJ Food from different brands. But that won't be very helpful, right? So you have to do all that calculation in the algorithm. So these kind of things, they are complicated. So I wouldn't set an expectation here saying that anybody can do that. Anybody can take this app and plug it into whatever you're doing, right? But to actually build something like that takes years of research, and that's where we depend on whatever is being built in Microsoft. So Xbox Recommender System is being used here, and for ranking the patterns that we have identified, we use the Bing ranking engine. Now, the last piece, basket-specific recommendation, is using the same model, but with a little twist to it. So it's still a latent factor model, but in this case, it's personalized. And it's not personalized to a person as such, it's personalized to your basket. Right? So it's taking all those items in the basket and then making a recommendation. So it has all those things like in the item-specific recommendation. On top of that, it also has something called training on the fly. And this is very powerful, and nobody allows, well, there's very few models out there which allow you to train the models on the fly. So the model is trained to do one item. It's not trained to do all the different items. So it does that on the fly and produces the results. And you saw live, right? I'm using a test server, which, it's a normal server, but it's really quick. And it's quick enough for JJ to actually put these things on the mobile devices. Okay, so good so far. Any questions? So Thomas, your question was whether this thing includes promotions.
Yeah.
So simple answer is no. No, it doesn't include promotions at this point. Okay? That's a very big and very difficult and very different subject.
But wouldn't that be a part of novelty?
Yeah, I mean, I get the scenario, absolutely. But it's difficult to plug in promotions into the algorithm like that. But what we could do is we could still, you could do on Dynamics side is that when somebody is, for instance, usually bought together, right? So when the model is producing the results, right, then you get an item. Okay, so this item is usually bought together with it. Then you can look up in AX and see, are there any promotions running on similar items? And then expose that item instead of exposing the item that the model is suggesting, right? Okay. So there are different ways of solving it. Yes, please.
Can you expand on the distinction between frequently bought together and item specific?
Right. So the frequently bought together, we tell the algorithm that we are looking for a particular pattern. Which 3 items go together? That's the pattern. That's the only pattern we are interested in. Whereas in item-specific recommendation, we don't tell the pattern. Model is smart enough to look at a latent factor, and that factor could be things that are cooked together. And you don't have to specify that. Then things that are cooked together is a factor. It'll try to identify the pattern in the data, right? Or it identifies the pattern, and then it says that, okay, being cooked together is a factor. Then the other factor could be basic materials, basic ingredients that everybody requires, right? It's something very common. So if you watch movies online, for instance, on Netflix, you will have these recommendations popping up based on the movies you have watched. You don't have to say to the system that I want to watch only action and adventure, for instance, or I want to watch only foreign films or blah. System will automatically decide that the movies you have been watching have the genre of action and adventure, so you are most likely to like other movies like that. So there are similar solutions which do this latent factor modeling. But nobody does that with the Xbox Recommender is the most advanced algorithm. And then when you put that on Azure ML platform, you get the benefits of using that as an API. Yes, please.
Is this Xbox Recommender or any of these Azure app algorithms available through the studios? Are they publicly viewable, or is that a proprietary Microsoft product that you don't actually see?
So the algorithms are available through the studio, but I would not know the detail of if every algorithm that is being used is available in the studio or not. I think we are slowly adding everything to the studio. The app is not available because the app has, of course, the basic algorithms plus a lot of computation and data transformation inside, so that's not available. Any other question at this point? Yes, please. Sorry, say that again.
Is it not effectively the same thing from the consumer's perspective? I'm interested in these ones, and therefore you're recommending those ones.
Yeah.
If it's the same from the consumer's perspective, wouldn't they both serve the same purpose? And therefore, would JJ want to just find out which one converts the most and then use that one in both scenarios?
Sorry, which both would be?
Frequently more together and item-specific recommendations.
Right, so the difference is item-specific recommendations allow you to actually produce novelty. They will recommend stuff which you normally don't buy. Okay, usually bought together can also do that because it's looking at the baskets of all the people. So maybe one customer doesn't buy all these, so it can also produce that. But item-specific recommendation looks at, like I said, all the different latent factors. So it still produces very different results than the usually bought together. Usually bought together is not a predictive model.
Different results, but could be used in the same scenarios for a retailer, and therefore would the retailer not want to know which one of the two?
Absolutely. Yeah. I mean that you can hide. You can hide that from the customer. Absolutely. Right. Okay. So I'll move on now and then take the questions later. So let's look at what they have achieved with this. Okay, so this most of these things have been live for 4 months, and first time we showed this was in Convergence when it was only live for 3 weeks, and the CEO from JJ Foods, Mushtaq, he was very nervous when he showed this in the keynote because it's only 3 weeks. But now we have data for 4 months, and so if you look at the business challenges, so I've covered this with the business challenge, right? The first thing, if you remember, was that as they moved to the web shop, half of the business moved to the web shop, they lost the cross-sell, upsell opportunity. And to tackle that business challenge, we've put these models in practice. And so far, about 1 million predictions have been served. Consistently, 20% of recommended items are being put into the cart. Now, this is very important, and this is where I'll talk about something called A/B testing later, but it is really important that your website and your call center stays optimized, right? Because the catalog changes and how people interact with the catalog changes, people's requirements change, and so on. So things move quite a lot, and you don't want to get into a position where you are showing recommendations but nobody's using them, okay? So 20% is a very, very healthy number, okay? So 1 in 5 recommendations are being put into the cart. That's solid. And the recommended items in the cart, if you take the whole cart, right, whole cart across all customers for these 4 months, 3 to 4% are coming from the items that were recommended by the system. Okay, so that's the cross-sell opportunity right there. Right. Then improving the customer service. So that's, I mentioned likely to buy, but that's the same thing as basket prediction. So we wanted to improve customer service, so we predict the basket for the customer. We still have to do some A/B testing here. But the anecdotal evidence is that it is not complete yet, but it is helping them on the orders, online orders. So there's retain customers. Yeah, that's the customer churn and customer classification. So customer classification I showed a little bit. It's a mining model which tells you which customers have been buying regularly with other parameters included. And that really helps a call center agent to decide what to offer and not to offer. And the customer churn is the experiment which we are still running. And what it does is, so the purpose of this is really to identify who are the customers who are most likely to leave. Okay, so there are many different techniques. Customer churn is not new. It's been in the telecommunication industry, financial services for a very long time. We're applying this to retail now. So the model that we've been running, it has been correctly showing that 64 customers out of the top 200 are likely to leave. Okay, so which is a very good number. Well, we still have to practice this. So how you can use this information is that if you know that these 64 customers are likely to leave, you can ask your marketing guys and sales guys, depending on your business, to go and talk to these guys, right? So you have pinpointed, based on all the behavioral patterns that you have in your system's data, and like Azure ML, you can add other sources, data sources, if there was something else somewhere, like, if you had a business where there was a lot of Twitter feed, you could add that to do this calculation. And so you've identified that these 64 guys, they are not going to be there next month. We need to take some action right now, okay? So that's what they're working on right now, and we'll see how it goes. Okay, so now, what is Azure ML? So this is high-level slide. First of all, it's fully managed service, okay? You don't need any computers. You don't need to put anything in your own data centers. Microsoft takes care of everything. Only thing that you need is an Azure subscription. Actually, there is also a way, if you just are very keen to get started, you don't even need Azure subscription. You can just use your live ID, and you can start playing with the Azure ML Studio. Next thing is, I talked about a few times about this, is the integration. Drag, drop, and connect interface. Data sources, just like a drop-down, right? So when you see the studio, you will realize that you can just add any type of data source. We are constantly expanding the type of data sources you can add, but still adding the data sources that we allow you to add is just a drop down right now. And it's really, really fast. And same thing, okay, I'll cover that later. So flexibility. So built-in collection, best of breed algorithms, to your point, right? And we say no coding required. Many models can be built with no coding required. But sometimes you do need to do a few things. And for that, you can use the language R, which is very popular in the data science community. Or you can use some popular CRAN packages. So fully managed service, integrated, flexible, and you can deploy it in minutes. Okay? And what I mean by deployment is, so you've taken all this data, you've built all this fancy model, and now what to do with it? So that's what I mean by operationalizing the service. And you can just with a few clicks operationalize the service, and then you get a REST endpoint, and then you can just use that endpoint wherever you want. So that's what we've done in case of JJ. We're using several, we're calling several of these within AX and on the website. Next thing, so there's a little bit more detail on how it actually works here. So the business challenge here, like I mentioned briefly before, has been that number of, it takes a very long time. Time to value is very, very long, has been very, very long in the past. But now in the cloud, you have all this data available. With drop-downs, you can put that into your Azure ML Studio. You can take data from your on-prem systems. It's no problem. It's not just a cloud solution. Don't think, like I showed you, JJ runs on-prem most of the time. So you put all that in ML Studio, and that is, ML Studio is basically like Visual Studio, right? That's where you write your model. And once you've written your model, then you can publish it as an API. And if you see in the bottom there is the Azure ML apps. And we have some packaged apps which are available in the marketplace. And then basically, like you have seen, JJ is doing it on storefront and on AX client and on mobile device. So you can expose that to the clients. Now this is where I want to spend the rest of our time to talk about how we can use this in Dynamics more. So this thing I mentioned, right, cross-sell. So you're aware, some of you are aware of this capability, which is exposed in the call center, right? So here you can see this is what we provide right now out of the box. So you go on the, I think it's in the product information management. So you're standing on a particular item, and then you open this form, and then you will say that for that particular item, based on that rule, which you can specify there, you can sell this particular item. So imagine, even if you had a small catalog of 3,000 items, how many rules you need to set up, okay? So what simple thing we could do here is that instead of having that, we could augment it or just completely replace that by using recommendations from Azure ML. Right? We could add some additional parameters in AX if you wanted to decide which type of recommendations to expose, based on the score of them and the probability and the relevance. But really, you could maintain your cross-sell and upsell within AX based on that. Next thing, how many are familiar with related products? Okay, so half of the audience, that's great. So related products, so what you can do here is, right now, again, on the product information management, you have, you're standing on one item, and then you say this item is related to this other item because it's frequently bought together, okay? And then you can create this for 3,000 items, or you can multiply that, 27 billion times, and then you have 27 billion records, and then you have made sure that you will always be able to surface these recommendations, right? So once you actually do this, then in AX for retail, these things get exposed on your modern POS and on your storefront. So what we can do is, again, the same thing, right? Why do we have to create these by hand? Why do we have to make these, maintain them? Product catalog changes all the time. So that's another scenario where we can do that very simply. Then there is something called items list when you're creating sales order. And what this item list does it's available on the sales order line action pane. So if you drop that down, then one of the options is items list. So what it does is that it looks at how it creates a distinct, all the distinct items that this customer has bought over a certain period. And then it shows those items here. So it's the same thing. We could just simply say that we want to replace this simple static list to a basket prediction service, right? And this will be, of course, customer specific. So you're already predicting what the customer is likely to buy. You're using an Azure ML model, and you put all of those items here. When the call center agent comes to create a sales order, the first thing he does is looks at the item list. And he can select all and drop them. Suddenly, all your sales lines are created, and created in a very smart fashion. Okay? Then on the AX call center, there is something called the RFM score. And there is some math behind it, but you can see what the math is behind it. What you could do is, you remember the classification, the gold, diamond stuff that JJ has created, right? It's more or less similar, right? So that's why what we're doing there is exactly, not exactly, but similar to that. So again, you could use that. You could create an Azure ML model, right, and expose whatever the RFM interface is. So trying to do things where you don't have to go create new AX forms and new AX screens, just starting very simple, right? So this would be my advice. If you're interested in this area, go and look at what the apps are available. So you don't have to go and learn all the modeling stuff. Look at what apps are available. Look at how and where you can plug them into AX, right? And this is something, apps are in public preview, so they are free of charge. If you have an Azure subscription, if you have the data, you can start using them now. Okay, so you feed the data to the app will give you the result, and then make sure that you call that result in AX, and then fill the backend tables here. Okay, so this is another possibility. So we have trade agreements. We had trade agreements for a very long time. What you could do here is you could consider, based on the churn results. Churn is also an app. So based on the churn results, you could say that, okay, these 64 customers are very likely to churn. You could pick those customers and, based on some logic, or you can just say that I want to put them into a lower price group. Right? They are likely to leave, or you can do this after your sales agents have spoken to the customers and customers have complained that the prices are too high. You can have some automated functionality which puts them into a lower price group. Create a journal, post it, change the trade agreements. Okay? Now, these are some of the things that are very evident, and we can do them. But then, that's not the end of it. Now I want you to think about other scenarios, right? There's lots of other things we can do. And so, for instance, fraud detection is a very common machine learning problem, and there's, I don't know, maybe thousands of different applications which do fraud detection in different scenarios. Right now, we have fraud detection I think in the call center, yeah. And we have some math behind it in AX, but we can definitely improve it. Because fraud detection takes a lot of data science, and it takes a lot of different data sources, right? So why depend on some simple rule-based system when you can augment it with something much more clever? Forecasting. Forecasting is a prediction, right? So we are working together with the Azure ML team on a number of forecasting scenarios. So you can forecast, and then you can feed that forecast to the MRP engine. Calculate reorder point. Today in AX, there's no way to calculate. As far as I know, you have to tell what your minimum quantity is, right? So why can't we calculate that based on the stock movements? Why can't we calculate safety levels and update the minimum inventory, depending on your scenario? Why work with a static minimum inventory when the reality is that things change all the time? Predict who is likely to default on payments. So you have all payment transactions, right? Your collection agents are running around and chasing the people who they think are less likely to pay, right? Why don't you use a model to predict the customers who are less likely to pay? And then put that on the top of the collection summary. Predict what leads are likely to become into opportunities in CRM. Use various features to identify patterns and predict loyalty and longevity. Many different things you can do on CRM. Then in manufacturing, we can use sensor data to predict machine or part failures. There is an app on Azure Data Market which is called anomaly detection. And it detects anomalies in your sensors. Well, anything. It can detect anomalies. We use it for, I think, for our data centers. So it can detect anomalies on what's likely to fail, which hard drive is likely to go and which node is likely to fail. Something similar, right? We have so many customers and partners in manufacturing, and they are already collecting all this data, which is probably going into some sort of a data warehouse. Why can't we use that, and why can't we predict which machine is likely to fail? There are scenarios which wider Microsoft, lots of other teams are working with other customers, non-Dynamics customers, to enable these things. All right. And I mean, if you can predict which machines are likely to fail, you can use that in your service management. You can use this to do so many things. You can make sure that the parts that are likely to fail at the customers, let's say you're an IEM business and you have these big machines which are installed at different customer sites. Right now, you have to wait for the customer to call you after the part has failed. Then you have to fly the part and fly the service guys to go fix it. If you could predict that based on the sensor data that's coming out of these machines, whether these machines are internal or at the customer site, you could make sure that those parts and the personnel were pre-planned. Right? There are companies which are creating new businesses around this. Or if that's too far, we have the anomaly detection service. We can just detect anomalies and send alerts to stakeholders. We can mine buying patterns, like we've seen several examples, and move customers among price groups to maximize the margin. Or we can simply mine buying patterns and find out what's the floor and the ceiling price for a particular customer, for a particular product. And we can also do that with quality data. We have lots of quality data being captured in AX. We have lots of quality data being captured in systems other than AX. We can put all of that together. We can find out what is the minimum and the maximum level of quality. What's really the accepted quality level? Today we work with a fixed accepted quality level, beyond which customer will not accept. We assume that. But if you look at all the batches you've been sending to the customer at different quality levels, you may be surprised to find that actually it's okay to send something which is not at the level the customer says because they've been buying, right? And you can, I have only those I could come up with, but there are many, many similar scenarios. And I want you to think about this and tell me if you have other scenarios and other customers ready to work with us. And we can create a lot of these things for them. Okay, so So this is the summary. So we've seen all these things, and this is on the PowerPoint deck will be available. So I won't go through that. My intention here was to summarize, but I think I've been summarizing all along, so I won't bore you with that. The key learnings. Machine learning is already all around us. Many companies are already selling ML-based products and services. Every problem can be solved with many different types of models. So remember that there's many people who have created all these models in the open source community. Many of these you will find on the Azure ML Studio, and many others you can find through R packages, which you can upload into the studio. We support, I think, about 400 different R packages, and we will be supporting a lot more in the studio. Every model will have a different result set. It's important to remember that this is not which can solve every problem. And every result will come with a probability. Okay, so there's no clear-cut result, right? It's never 100%. That's what prediction is about. So use testing techniques to test the results. And choose the model, measure the business impact, and then choose the model that works for you. So you need persistence, you need to work. It's not like, I don't want you to leave with this impression that if you plug the studio and plug the apps, then everything is done. You have to do the testing. It's important to be able to understand what the result is telling you and have a little bit of statistical insight into being able to read the result. As the business changes, iterate and experiment. With Azure ML Platform, experimentation is super simple. And with Azure ML Apps, it's easy to get started. Many are in public preview and more to come. And for other problems, use the studio. Having skills in R and knowledge of statistics is important, but strike a balance whenever I do these projects, everybody wants to know what is happening in the algorithm. And we spend weeks and weeks talking about what's happening in the algorithm. And I think what's important is you need to know at a high level, fair enough, but the focus should be on how you can use it, right? Businesses in the applications, not so much into what the algorithm is doing. So unless you're an expert, get past the need to know the algorithm inside out. It's just math. Okay, so there are some other content here which you can go and look for later. Questions? Yes, Thomas.
Workload.
Please fill the feedback forms. Thank you.
Workload and performance, what to think of when doing this? When you start these queries, will it be stressful towards the AX database or cloud database? Or?
I don't believe so. I mean, you just need to pull data out of AX. You can do a bad job. Once the data is outside AX, you have to upload it. And there is something called Azure Data Factory, which will become more and more prevalent. And this data factory allows you to do data ingress and egress and do some basic transformations on it. If you need more compute, that's why cloud is there. All right.
What was the question?
Sorry, the question was performance. Will AX notice the performance? Or will your queries on the cloud take a long time or not? Sorry, yes, please.
You mentioned that everything needs to be loaded where you be able to do this.
Right, absolutely, yeah.
So in order to keep the accuracy of the data, that process needs to be.
Yes, that's what I said. There's something called Azure Data Factory, and that is data orchestration pipelines. You create your data pipelines in that. So you can schedule the data upload. So some data you want there to go weekly, some other nightly, and some other monthly. You can do that. It'll pick data. So right now, this is, it's a customer example, but we're working towards making all these things very easy for you. So hopefully in future you can go to, let's say, lifecycle services, where you have all your environments, and you can point to a particular environment where you want to pick the data from, right? And there will be Azure Data Factory that will pick this data and schedule it, send it to the model. The key thing about data that you have to remember is that the data that goes into the Azure ML has a specific storage for it. So when you create a workspace for yourself, then there is a specific storage assigned to you, and that's where the data is kept. And we only need the training data, okay? And you can also, so if there are privacy concerns, you can actually encrypt the training data, or you can obfuscate it. You can just give us what we really need. And usually there's like 3 or 4 things. Like for frequently bought together, we just need the transaction ID and the item ID. Okay? So we can work through those things if you want. Yeah.
Do you make the sample AX apps that you showed available on the demo image that's published with
I would love to. Well, we're working through that right now. So what I showed you are ideas. The Azure ML apps are already available in the Azure Marketplace. The integration to AX is not available anywhere yet. So we'll work through that, and as Mike mentioned in the keynote, there's many different teams. So you will see more of this in future, where we will have a clear data pipeline and clear integration to these services available. Yep. Any other questions? Yes, please. Yes, I think so. I should have been repeating the questions.
I have a quick question about the ML marketplace. If we as I understood, 3 of the 4 examples you had were apps that were taken from the marketplace, right?
Yes.
And is there a mechanism to guarantee that this, if someone implements a use of some app, let's say the frequently bought together app, is there a mechanism to ensure that this algorithm works the same way and is not impacted by developers' upgrades? Is there a way to freeze the version of API if it's implemented?
Okay, so when you buy the app on the Azure Marketplace, so they will give you some guarantees, whatever they give you, you will see the guarantees over there. But if you're asking me about the upgrades to AX doing something to the app, is that the question?
No, the upgrade to the, let's say developer decides to change the algorithm or upgrade the model.
So
But-
as far as apps are concerned, you cannot change, you cannot see the model, you cannot change it. Azure ML Apps is a packaged product, it's a black box, the algorithm cannot be changed.
Yes, but as a consumer of this app,
Yeah.
is there a way to guarantee that any further upgrades are not automatically published into like production, let's say?
Absolutely, I mean that Azure takes care of that. And if there is an upgrade to the app, it will be a new app. You will have to go through the process of buying it and deploying it yourself. So it's not something which is automatically pushed out.
Okay.
So if you're using an app in your live environment somewhere, it's not going to get replaced with something else.
Okay. And the second question, I kind of browsed the marketplace and it looks like there are third party, they are not Microsoft apps that are published by someone. Is there a review process that Microsoft does to allow something published, or it's...
Absolutely. So there is a whole review process. I'm not privy to the details of the review process, but not all the apps are third-party apps. So if you look in the data services in the marketplace, there's a number of apps which have been published by Microsoft, but of course it's a marketplace, so all other partners can publish their apps as well.
Okay, thank you.
Yep. There was a question here?
So with, if you wouldn't mind, is there any built-in analytics for trying to say whether or not the predictive models are actually making positive results, or do you have to handle all of that separately?
No, if you use Azure ML Studio, there's really quite a lot of descriptive statistics inside the studio itself. So on every node, you can right-click and see, how the model is behaving, and you can do the scoring by yourself, and it'll tell you.
You came up with that like 20% statistics or things that go into a basket type of thing. Is that already coming from the app, or was that something that they did like afterwards? They analyzed.
So the 20% thing is actually coming from the web shop integration. So there is an integration which you can do to collect click events from the web shop. So every time there is a click event or every time there is an add to basket event, we are capturing that data. So we know who's clicking on recommendations and how many recommendations are getting into the basket. Okay? Okay. Anything else? Okay. Yes, last question, please. So that's a question I can't answer about the roadmap for the modern POS. But if you are attending a session with the retail folks, you should definitely ask them there. Okay. So if you have customers, scenarios you're interested in working with, please come and talk to me. We are looking for these projects. We are looking for building different templates. And yeah, we can get started very, very fast. Some of these things, if you're using Azure ML Apps, if you give us the data, we can show you the results in a couple of days. Okay? So if there are no more questions, thank you so much for coming.